Distinguished viewers all over the world, welcome once again to Simplified Maths Class. I remain your host, Mr. Mike Omeni, and today I bring you the topic, the sine and the cosine rule. Now understand that the sine and the cosine rule is very key in solving bearing and distances. There is no way you can have a fair idea about how to compute bearing and distances problem except you have a very strong idea about the use of the sine and cosine rule. Although in some rare cases, SOHCAHTOA or Pythagoras theorem can be used in solving bearing and distances, but it's in very rare cases. Majority of the problems you meet in bearing and distances are anchored on the concept, the sine and the cosine rule. So without waste of time, we will treat the sine and cosine rule effectively. Now, if you have not subscribed to our channel, Simplified Maths Class, please kindly do that by clicking on the red subscribe and on the bell notification, and God bless you as you do that. Alright, so the sine and the cosine rule. Now, I have left the space here so that you can have enough time to copy the notes. It's very important. The sine and the cosine rules are both used in solving triangles that are not right angle triangle. If a triangle is right angle, you use either SOHCAHTOA or Pythagoras theorem, as the case may be, to solve the triangle. But when the triangle is not a right angle triangle, you either use the sine rule or the cosine rule. Now, based on certain conditions. Now, the use of the sine rule. The sine rule is used in solving triangles that are not right angle triangle, provided two conditions prevail, which means that either the triangle has two sides and one angle given, or two angles and one side given. The condition is SSA or AAS, meaning SSA is two sides and one angle is given, while AAS means two angles and one side is given. That is the condition for you to use the sine rule. And by the sine rule, the formula is A all over sine A is equals to B all over sine B, which is equals to C all over sine C. But understand that we don't use the 3 at the same time. It's either we are using A over sine A equals to B over sine B, or we relate A over sine A is equals to C over sine C, or we relate B over sine B is equals to C over sine C. I will show you how we can handle that perfectly. But this is for a triangle that has the sides A, B, and C. Alright? So the formula can be adjustable if the triangle is PQR or XYZ, as the case may be. Alright, now but the cosine rule. The cosine rule is also used in solving triangles that are not what? Right angle, provided the following two conditions prevail. Number one, either that the triangle has three sides given, which is SSS, or it has two sides and an included angle given, which is SAS. Take note, it's very important. Now understand that SAS is different from SSE. As we have in sine rule SSE, this is different from SAS. Now SSE meaning two sides and one angle, but the angle is not in between the two sides. Take note of that. But if the angle is in between the two sides, which is SAS, you must have to use the cosine rule. So those are the two conditions for the sine rule and the two conditions for the cosine rule. Don't forget, for the sine rule we have SSA, two sides and one angle, or AAS, two angles and one side. Use the sine rule. But if you're using the cosine rule, it means you're using the cosine rule when the three sides are given, SSS, or two sides and an angle in between, an included angle is given, which is SAS. Please take note of that. Like I've said before, the sine rule, you have A over sine A is equals to B over sine B, which is equals to C over sine C. But if you have the cosine rule, if you're looking for the sides is what you're looking for. You're using this three formula. So if the side you're looking for is side A, you're using A squared is equals to B squared plus C squared minus 2BC, the cos angle of A. If you're looking for B squared, the side B, it means A squared plus C squared minus 2AC, the sine angle of B. Sorry, the cos angle of B. And if you're looking for the side C, which is C squared, we have C squared is equals to A squared plus B squared minus 2AB, the cos angle of C. That's how you find the sides A, B, and C using the cosine rule. But if you're looking for the angles, capital A, B, and C, those are the angles. You either use, if it is the angle A you are looking for, so you use cos A. And cos A is B squared plus C squared minus A squared all over 2BC. Sorry. Alright, so if you are looking for cos A, you have B squared plus C squared minus A squared all over 2BC. If you are looking for cos B, it is A squared plus C squared minus B squared all over 2AC, which is this. And if you are looking for the C, it means cos C will be equals to A squared plus B squared minus C squared all over 2AB. Alright, so that's how we find the angle. So these three formulae are used in looking for the angles capital ABC. Alright, why these three sides or these three formulae are used in looking for the sides small a, b, and c. Now, I am going to set some examples here for us to solve problems either using the sine or the cosine rule, which means I'll bring out a triangle. I will now decide on which of the formulae to use, whether the sine rule or the cosine rule, based on the prevailing conditions. That is the next thing we have to do. Please take notes. All right, so let's take some illustration. Now, if you have your notes already, they are very key, very important. So let's take some illustrations. Let's say you've been given a triangle. Given the triangle ABC as shown below. All right, so this is a triangle that is not a right angle triangle. Now let's say this is A, and then this is B, and this is C. Now assuming here is given as 6 cm, and then here is given as 9 cm, and then let's say this angle is given. This angle is given, let's say 30 degrees. And let's say you've been asked to find this place. You've been asked to find this place. So this side is what we call small a. Small a is the side that is facing big A. All right? Now this side is called small c because it's facing the big C. While this side is called small b because it's facing the big B. So in this situation, we are asked to find this side, which is the small a. Now, if you look at this, you see that two sides were given, but not the included angle. Two sides and one angle is given, but note that the angle is not in between. So it means the condition here is SSA. That's the condition here, SSA. Why? Because we have two sides and one angle given. But take note, the angle is not in between. The angle is either here or either here, but not here, because if it is here, the condition changes. It becomes SAS. All right. Now, but what we have here is SSA. It means two sides and one angle are given. And now you have been given this, facing this. Let's say, for instance, the first thing they will say is, let's say we should find this other angle. We can be asked to find this angle. All right. We can be asked to find that angle. Maybe after that, before we can be asked to find this side. Now, we want to find this angle. Notice that this angle is facing this particular side. While this angle we are looking for, let's say that angle is something. We are looking for this angle. Is the angle we are looking for. Let's call it theta or anything. While that angle is actually facing this other side given. Now, the condition here is SSA, which means we have to use the sine rule. Now, let's define the parameters given here. Please take notes. Now, this is big C. The side facing the big C is small c. So, small c is equals to 9 cm. Please take note of that. All right. Now, this is big B. The side facing the big B is the small b. So, the small b is given as 6 cm. Please take note of that. The small b is 6 cm. This is the big B, this is the small b, 6 cm. This is the big C, and this is the small c, 9 cm. And we've also been given angle C. Angle C, that's the big C. Angle C is 30 degrees. Angle C is 30 degrees. And we are looking for angle B. We are looking for angle B. That's what we are looking for. Now, if you look at it, you will see that what we have is in terms of B, big B, C, big C. That's what we have. So it means that because we've been given SSA, two sides and one angle, from the notes I've given you, you know that you are to use the sine rule. You are definitely to use the sine rule. Now, understand that by the sine rule, you have A all over sine A is equals to B all over sine B, which is equals to C all over sine C. But what we have is in terms of B and C. So it means you're going to use the sine rule. You're going to use the sine rule, but in this way, only B and C is involved. So that would be B all over sine B is equals to C all over sine C. That's what it means. So that's how you're going to apply the sine rule. You know, remember that the sine rule is A over sine A is equals to B over sine B, which is equals to C over sine C. But I've made it to understand that you cannot use the A, B, C at the same time. You must always use two at the same time. Now, before you decide on the two to use, you must compare to see what and what is given. That's why we had to check. We had the big C, which is 30 degrees. We had the big B, which we are looking for, theta. We are looking for it. This is the one we are looking for. Let's call it theta, or you leave it blank. And you have been given the side facing the B, which is 6 cm. That's the small b. And you've been given the side facing the C, which is 9 cm, and that's the small c. The side facing C is small c. That's the 9 cm. Now, because your parameters are defined in terms of B and C, so in the sine rule, we are going to use B over sine B is equals to C all over sine C. So let's see how we can do that. How do we use that to now solve a problem, the sine rule? Please watch carefully. It's very important. If you know this very well, it will be very easy for you to solve problems that involves bearing and distances. So how do we do this? Small b now is given as 6 all over sine angle of B, which is sine angle of B theta, because it's the one we are looking for, theta. So let's say the B is theta. So B, small b is 6. Sine B is sine theta, because we are looking for theta, is equals to small c, that's 9, all over the sine angle of big C, and the big C is 30 degrees, so sine 30 degrees. So it means we are going to look for what theta will be. So what do? We cross multiply. So we are now going to have this times this will give us 9. The sine angle of theta is equals to 6 times this will give us 6. The sine angle of 30 degrees. So we are going to have sine theta, which is what we are looking for. The sine angle of theta will be equals to 6. The sine angle of 30 degrees all over 9. Because we are trying to look for the sine angle of theta. So our sine angle of theta will be equals to 6 times the sine angle of 30 degrees should be 0.5 all over 9. So let that be confirmed. The sine angle of 30 degrees, that's 0.5, that's correct. So 0.5 times 6 will give us 3. So the sine angle of theta will give us 6 times 0.9 will give us 3. So 3 divided by 9. So we are going to have 3 divided by 9, which is going to be 3 divided by 9. Okay, so that's 0.3333. So what we did is to take 6, multiply by 0.5, and then divide the result by 9. So that will give us 0.333. So what will be the theta now? Your theta now will be the arc sine. The arc sine of 0.3333. That's the inverse of the sine. We call it cosecant. Alright, so that will be the arc sine of 0.333. How do you operate that in the calculator? You say second function of sine, that's the arc sine. Second function of sine of that 0.3333, and that will give us 19.47 degrees. So that means our theta will be 19.47, which is 5 degrees approximately. So our theta is 19.5 degrees. So the moment you work that, the sine angle of theta is this. Theta will be the arc sine of 0.333. That's the inverse of sine of 0.333. And you do that by pressing second function sine 0.3333. and that will give you 19.5 degrees. It therefore means that the angle we are looking for here, theta, is 19.5 degrees. That's all. So we've been able to apply the sine rule using SSA. All right, sometimes you apply the sine rule using AAS. Let's take that as a second example. Let's say we've been given AAS. How do we apply the sine rule? So let's try something else. Okay, now let's say we've been given a triangle that is defined in terms of PQR. Given the triangle PQR as shown below. So this is another triangle. Let's just bring out the triangle. All right, so this is P, this is Q, and this is R. We want to apply that. Okay, let's say for instance here, the other one was we used two sides and one angle. Let's use two angles and one side. Let's say you've been given here as 40 degrees, and you've been given here, let's say, as 60 degrees, and then probably you've been given this side maybe 55 meters, and you've been asked to find this side x meters. We want to find this, and of course note that this side we are looking for is small p. We want to find here, we want to find this place, which is a small p. That's what we are looking for. But understand that this is the big Q, which means this side is small q. Now this is the big P, this side is small p. So our parameters this way. Now let's say we've been given this triangle. They say we should find, now let's say we should find QR, line QR, and please understand that line QR is a small p. The line from Q to R is a small p. Understand that. So we want to find the small p. Now if you look at this, you see the condition that was given here is that they are giving two angles and one side. So what you have is angle, side. That's what we have. So we have angle, and one side given. So it means we are going to use the sine rule again. Why? Because the sine rule is also used for angle, side. So how do we apply the sine rule? By the sine rule now, you will know that we are supposed to have P, small p, all over sine P by sine rule. I've told you it will not be defined only in A, B, and C. It can be in PQR. So P all over sine P will be equals to Q all over sine Q. And that will be equals to R all over sine R. So that's the sine rule. Instead of having A over sine A is equals to B over sine B equals to C over sine C. Now the triangle is defined in terms of PQR. So it means we have P over sine P all over Q over sine Q. Is equal to P over sine P is equals to Q over sine Q, which is equals to R over sine R. That's what we have to have. Now, but look at it. The parameters given here, small p, is what we are looking for. They have given us small q, which is 55. All right, and we have a big P, the angle, which is 40 degrees, and then we have a big Q, the angle, which is 60 degrees. So you can now see that here the sine rule is applied in terms of just P and Q. So which means out of the three we are picking P and Q. So that will be P all over the sine angle of P is equals to Q all over the sine angle of Q. That's what we are going to have. So what is our P? Our P is what we are looking for. All over the sine angle of the big P, which is 40 degrees, is equals to Q. Q is 55 all over the sine angle of the big Q. The big Q is 60 degrees. So we cross multiply. We have P times this will give us P sine 60 is equals to this times this will give us 55 sine 40 degrees. So we are now going to have that our P, which is what we are looking for. P now will be equals to 55, the sine angle of 40 degrees divided by this, which is sine 60. So that's what we are going to find. So let's see how we can complete that this other way. So we are looking for our P now will be equals to 55 sine 40. So that would be 55 times the sine angle of 40 degrees. Let's see, sine 40 degrees. Sine 40 will give us 0.6428. 0.6428. So we divide by the sine angle of 60 degrees, which is 0.8660. So our P will be equals to, so this times 55. Now we now divide by 0.8660. So if we multiply this by this and divide by this, we are going to have 40.8 degrees. 40.8 degrees. So that, 40.8. The speed denotes the side, so that will be 40.8 in meters. Alright, so what we have is 40.8 meters. We are looking for small p, which is the side QR. So that's 40.8 meters. So you can now see that we have applied the sine rule when two angles and one side is given. Just as we apply the sine rule when two sides and an angle is given. Alright, so that's how we apply the sine rule effectively. Okay, so in our next slide, I'm going to show you how we are going to apply the cosine rule effectively. Even though we have been given the cosine rule, the formula for the cosine rule, in the next slide, I'll be showing you how to apply it in solving problems. Now, understand that if you can actually do this, which is the sine rule very well, and you can do the cosine rule very well, it means you are prepared for bearing and distances. Thank you very much for watching our slide, the use of the sine and cosine rule. And if you have not subscribed to our channel, please don't forget, click on the red subscribe and on the bell notification and personalize it. And please, if you have any question whatsoever or you have a comment for us, don't forget to drop it in the comment section or ask your question in the comment section. And if you enjoyed our video, please don't forget to give us a thumbnail. God bless you as you do that. Until we meet in the next slide, which is a part 2 of the sine and cosine rule, then I still remain your host, Mr. Mike Omeni. Please don't forget not to miss the second part of this, because you need the second part to be able to prepare yourself effectively for the next topic that is coming, which is bearing and distances. Have a wonderful day. Cheers.